So this is the second half of 3.1, so 3.1 part 2. Yesterday, we solved functions by graphing and by doing the square root of both sides. Today, we're going to be solving by factoring. Yesterday, we were factoring 2. We also factored last week when we had that intro to chapter 3. So you guys should be a pro at factoring now. So we need our left side of the equation to have our x squared, our x, and our constant, and then it has to be equal to 0 in order to be able to factor. And then this talks about the 0 property. So if we have two factors here, and it's equal to 0, if one of these numbers is 0 and the other number is whatever, it could be any number, 0 times anything is 0. We could also have our second little parentheses be 0, and our first parentheses be some other number. And we know that this is also going to be equal to 0 because some number times 0 is 0. So that's why we set both of these parentheses equal to 0 separately and solve for 0, because 0 times anything gives us 0. So we've been doing this before. This is nothing new. So let's jump right into our examples. So we are solving x squared minus 4x is equal to 45. So we need all of our numbers on one side. So we are going to subtract 45 on both sides of our equation. That way we have x squared minus 4x minus 45 is equal to 0. Once we have that equal to 0, we can start factoring. So to factor, we need two numbers that multiply to negative 45 and give us 4. So what would they be? So two numbers that multiply to negative 45 and add to give us negative 4.
9 and 5.
Awesome. 9 and 5. One of them has to be negative because it needs to be negative 45. So which one's going to be negative?
Negative 5.
9 minus 5 gives us a positive 4. We're looking for a negative 4, so it has to be a negative 9. So now we just plug both of these into our parentheses. So we have x minus 9 and x plus 5 is equal to 0. Now we split it up into two separate equations. So x minus 9 is equal to 0 and x plus 5 is equal to 0. So we get x is equal to 9 and x is equal to negative 5. So these are our two solutions to our equation, which is the same thing that we did at the start of yesterday. And then we use these two to graph our x-intercepts. This is the same thing. So our x-intercepts of this graph would be 9 and negative 5. All right. So now we have one that says find the zeros of the quadratic function. This is the same thing, except it gives us f of x, but we just change this to be 0. So f of x is just a fancy way of saying y. When it says find the zeros, we set our function equal to 0. So this is 0 is equal to 2x squared minus 11x plus 12. How do we factor our polynomial when we start with a number that's not 1? What do we need to do first?
Divide everything by 2.
We can only divide everything by 2 if all of our numbers are divisible by 2. If we divide 11 by 2, we get a fraction, and we don't want a fraction. So what else can we do?
Like keep it like on the outside of the parentheses.
We can't do that.
Combine the 2 and 12.
We multiply the 2 and 12 first. So we multiply the first and the last. So we get 24. Now we need our two factors of 24 that add and give us negative 11. What would they be?
-3 and -8.
Negative. Perfect.
Yeah.
Yep. Good job, Brooke. -3 and -8. So now we put those into our parentheses. So we have x minus 3 and x minus 8. We can't forget about this -2 out front. We need to divide both of our numbers on the inside by 2. It's a positive 2, not a negative. We simplify if it can be simplified. If it can't, we move it in front of our x. So 3 over 2 cannot be simplified, so we move the 2 in front of our x. So we have 2x minus 3. And then we can simplify our second parentheses. 8 divided by 2 would be 4. So we have x minus 4. And this is equal to 0. What do we do next? What do we do next?
You
Set them
solve
equal
for
to 0.
them.
We set them both equal to 0. So 2x minus 3 is equal to 0, and x minus 4 is equal to 0. 2x minus 3, we need to add 3 to both sides. So 2x is equal to 3, and then divide by 2. X is equal to 3 halves. And then for x minus 4 is equal to 0, we add 4 to both sides, and x is equal to 4. So these are two solutions to our function. These are two zeros of the function. So solutions are the same thing as zeros. So pretty much solutions, zeros, and x-intercepts are all the same thing. These numbers give us both the solution, the zeros, and the x-intercepts. So these are all the same. So we need to solve the equation by factoring. We already have equal to 0, so we can just go ahead and factor. So we need our two numbers that multiply to 35 and add and give us 12. What would they be? Perfect. 7 and 5. So we have x plus 7 and x plus 5. We separate our two equations, so x plus 7 is equal to 0 and x plus 5 is equal to 0. So we get x is equal to -7 and x is equal to -5. Any questions here? All right, let's look at number 8. What do we have to do first here?
Move the 2 to the other side so it's equal to 0.
Perfect. We need it to be equal to 0, so we're going to subtract 2 on both sides. So we have 3x squared minus 5x minus 2 is equal to 0. Now we can factor. What do we have to do first to factor?
Multiply the 3 and -2.
We multiply the 3 and -2. So 3 times -2 is -6. Now we need two factors of -6 that add and give us -5. What would they be?
-6 and 1.
-6 and 1. Perfect. So we put those into our parentheses. So we have x minus 6 and x plus 1. But we can't forget that we started with a number that was not 1, so we need to divide both of our numbers in our parentheses by our number out front. We simplify, so we have x minus 2. If it does not simplify, we move it to the front. So 3x plus 1. Now we can split up both of our equations. X minus 2 is equal to 0. 3x plus 1 is equal to 0. X is equal to 2. X is equal to negative 1/3. Last two examples. So we need to find the zeros of the function, so we just change our f of x to be 0. So we have 0 is equal to x squared minus 8x. What do we do here when we don't have a constant that's being added to it? Do we have any greatest common factors that we can take out?
X.
X. We can pull out an x from both of our terms here. So we have x and then x minus 8. So now we can set both of these equal to 0. So we have x is equal to 0 and x minus 8 is equal to 0. X minus 0 is already solved. We don't need to do anything with that. That's one of our zeros of our function here. X minus 8, we need to add 8 on both sides, so we get x is equal to 8. So these are two zeros of our function.
Where are we?
We're on the last slide, going to the last example of yesterday's notes. So 3.1.
I'm sorry, what did you say? You're like
All right, let's take a look at number 10. What do we do first here? Okay, we change our f of x to 0. So we have 0 is equal to 4x squared plus 28x plus 49. What do we do next?
Combine the 4 and the 49.
We multiply 4 times 49. What is 4 times 49?
196.
So we need two factors of 196 that add up and give us 28.
Fourteen and 14.
Awesome, 14 and 14. So we have x plus 14 and x plus 14. What do we have to do now?
set equal to 0, like each one.
Before we do that, can't forget, important step that we're missing. We need to divide everything by 4. Can't forget about our coefficient if we start with a number that's not 1. So we divide both of our numbers by 4. We simplify, so we have x plus 7 over 2. If it does not simplify all the way, we take our denominator and move it to the front. So this becomes 2x plus 7. We do the same thing here, so we have another 2x plus 7. Now we separate it into our two different equations and set them equal to 0. So we have 2x is equal to negative 7. Divide both sides by 2. X is equal to negative 7 over 2. And we're going to get the same thing on this one because it's the same exact equation. So x is equal to negative 7 over 2. So these are two zeros of our function.